Hello, today we're going to talk about our very last topic from this unit, which is finding actual molecular formulas based on empirical formulas and gram formula mass. Just a quick review, a molecular formula is an actual formula for a compound showing the actual ratio of atoms that exist in that molecule, whereas an empirical formula is a lowest whole number ratio of atoms in a molecule. So we actually talked about this in our last unit. What's useful about empirical formulas is with certain analytical techniques, the piece of lab equipment you use might not actually tell you exactly what's in a compound. Like you might find out, for example, if you put glucose, which keep in mind is C6H12O6, if you put that into a certain piece of analytical equipment, it might tell you have a ratio of 1 carbon to 2 hydrogens to one oxygen. And if you reduce the molecular formula of glucose down to its empirical formula, that's what you get. But we might still want to know the actual formula, because different sugar, but actually the same empirical formula, but a different molecular formula. So these problems are kind of based on ratios, so we do have to keep that in mind. I kind of set up a little bit of an analogous problem for you to look at, and it's kind of embarrassing. It still has my maiden name in it. If I had 4 chemistry classes and an overall ratio, boys to girls, of 3.2, and I taught 120 students total, could we figure out, how many boys and how many girls I teach? So most people can pretty easily figure this out. So you would say, all right, 3 times something plus 2 times the same thing equals 120, or 5x equals 120. Oops. And, sorry about that. And, sorry about that. This would give us an x equals 24. So that means if I wanted to calculate my number of boys, my ratio is 3 boys to 2 girls. So 3 times 24 is going to give me my number of boys, which is a total of 72. And I have 2 times 24, or 48 girls. So my molecular formula of my students is 72 boys to 48 girls, which reduces down to my empirical formula of 3 to 2. So just a little review on how actual versus empirical formulas work. So a problem for us to try, we have a compound with the empirical formula CH4. Its gram formula mass, or actual molecular mass, is 48 grams per mole. What is the molecular formula for this compound? So the first thing we're going to do is find the GFM for CH4. And I have some great news for you. We're actually going to round our GFMs. We really don't need to be specific in terms of decimals and all that stuff in this particular part of this unit. So for CH4, we're going to do 12 for carbon, plus 4 times 1 for our 4 hydrogens, which is going to give us 16 grams per mole. Remember, this is just for CH4. That's not our actual compound. They're telling us we have a gram formula mass of 48. So since that's actually not our, we know that's not our actual formula, we're going to say, okay, and take the GFM for our true molecular formula, and we're going to divide that by that for our empirical formula. And 48 divided by 16 gives us 3, which means this ratio is still true for C and H, but we're going to just multiply that by 3. So CH4 is really C1H4. If we multiply each subscript by 3, we'll get C3H12. So that would be our actual molecular formula. Now, in order to check our answer, we can go back and we can actually calculate our GFM. So 3 carbons times 12 plus 12 hydrogens times 1, punch those all into your calculator, and you will get our 48 grams per mole. So that checks out. Good to go. Just another one to try here. We have NO2 is our empirical empirical formula. Its gram formula mass is 184 grams per mole. So we're going to do 14 for our mass of nitrogen, plus 2 times 16, giving us total mass of 46 grams per mole for our empirical formula. So we're going to pull down our 184 from the problem, divide that by 46, and this gives us 4. So it means we have 4 times everything in the actual formula. So instead of N1O2, multiply everything by 4, we're going to get N4O8. Again, you can check this. 4 times 14 for nitrogen, plus, 8 times 16 for oxygen, should add up to 184. Can't seem to do my math today, sorry about that. 184 grams per mole. So we got to check. Go ahead and try this problem. Pause the video, and I'll put the answer up in a moment. So you should have gotten C4H8O4. Your first step, you have 12 for carbon, plus 2 for hydrogen, times 1 each, plus our 1 oxygen at 16, gave you 30 grams per mole. Our actual gram formula mass from the problem is 120 grams per mole, divided by that 30 grams per mole from just our empirical formula, tells us that we are going to multiply everything by 4. So since you started with C1H2O, you end up with C4H8O4. To go ahead and do your check on this one, 4 carbons times 12, plus 8 hydrogens times 1, plus 4 oxygens times 16, should indeed add up to